Hello, everyone, and welcome to our webinar. My name is Marina Silva, and I am representing Integrated Global Services. I'm joining you here from England, and just so that we know that you can hear us and that you can see us, could you please type in the chat where you are joining us from today? And I will get this started. Thank you. Great. So right now we have Larry and Paolo here as well. And in this webinar, we will be talking about how reducing fired heater NOx and CO2 emissions will improve your ESG score. The webinar will take about 30 minutes and will contain presentations, an interactive question and answer session, and polls. You are welcome to type your questions in the questions tab on your right, and we will answer all of your questions at the end of the presentations. Some housekeeping before we start. We are broadcasting live, and some of you may experience technical difficulties. If you do, refresh your browser or switch to a Google Chrome browser, or you can dial into the webinar to get the audio. And I'll post the dial-in instructions in the chat now. And if you tried all of the options I described, but are still having problems seeing or hearing the webinar, just email me, and I'll put my email here in the chat with the screenshots and the description of the problem. Try to avoid communicating that in the chat because it can be disruptive during the presentations. And now we're going to welcome to the stage Tim Miller. Due to rolling blackouts in Texas, Tim has recorded his slides. He may join us for the live question and answer session if he has power later on. So let's get started.
Good day, everyone. My name is Tim Miller, and I serve as the Executive Director for the Republic of Kazakhstan for Integrated Global Services. I'm also a Senior Advisor for the Upstream Operations for IGS. I worked for 38 years for Chevron, lived in 5 different countries around the world, and I've worked for IGS now for about 2.5 years. I also serve on several boards of directors, including Kazmunagas, the national oil company of Kazakhstan. Now, I'm sure that most people are familiar with the environmental, social, and governance scoring and ratings, but let me just set the landscape a bit and give you some context around what we'll share with you today. As it says in the slide, ESG is primarily a grading framework used by investors to systematically evaluate risks in publicly traded companies. You know, the ESG issues are largely driven by asset management firms, pension funds, big investment firms that wish to have socially responsible investments in their portfolio. Also, shareholder activism is playing a larger and larger role in ESG in trying to leverage their power in ESG to turn the direction of the companies that they invest in. Also, a new industry has emerged, essentially industrial image consultants, companies that help you with your ESG ratings by packaging what you do already or by helping you with initiatives that will ultimately improve your ESG scores. On this slide, I've included a few snippets from websites of investment firms that highlight how they're focused on ESG as part of their portfolio and investment activity. Notably, in the BlackRock Sustainability Hub, I'd like to highlight that they call for a new standard for investing. So many of these companies are really changing the way they invest and are taking ESG into account in their decision making. Likewise, in the Vanguard slide, they say together we're changing the way the world invests. So no longer is it only returns or future capital improvements, but it's also, are the investments that we make sustainable? So all of these companies have this as part of their focus, and their investors are interested in the ESG scores of the companies that they invest in. On this slide, I've included a couple of excerpts from the websites of two international major oil companies. Now, as you can imagine, safety and the protection of the environment have been long-time values for these companies. But the broader aspects of ESG are now being included as part of their communication efforts. Now, most of the major companies now produce glossy sustainability reports that highlight the improvements that they're making in diversity, in the social responsibility in the areas that they work, but also in the reliable use of resources and the efficient use of resources and what they're trying to do to protect the environment and reduce their emissions. As we go forward, ESG starts to drive more and more of the behaviors of these major oil companies. So this brings me to my last slide, and current operators are really looking for opportunities to show they're making steps in the right direction. Nobody's expected to turn into a green company overnight, but investors are expecting that people are making efforts to improve their ESG initiatives and their ESG ratings. So what we'd like to share with you today are some steps that you can take and some examples that will speak to best-in-class reporting on efforts that you're making to reduce emissions and to improve reliability and the efficient use of resources. And with that, I'll turn it over to Larry.
Thank you, Tim. And now Larry will talk us through the practical ways of reducing CO2 and NOx emissions within your plant.
Thank you, Marina. And of course, thank you, Tim, for those opening remarks. Nice recovery on the rolling blackouts. It's obviously been a challenging week for a lot of people. So thank you for participating today. The ESG discussion, in particular the environmental component, really is a great platform for IGS to showcase what our technologies can do to make an impact on emissions. In particular, CTEC ceramic coatings, we can help the environment by impacting a way to lower CO2 and NOx. And of course, that comes in conjunction with the other benefits from the coatings, which is lowering your operating costs, fuel consumption, improving asset liability. All of that rolls into a very meaningful technology. So my name's Larry Amsch. I'm responsible for the CTEC product line, which is actually part of a full menu provided by Integrated Global Services. So what I should say about that is that we offer a whole product line that's based on proprietary high velocity thermal spray, which is uniquely suited to combat corrosion in units like amine vessels, etc. We also have created and perform a variety of online services that we call Hot Tech. And in that product line, we're repairing fallen refractory, we're cleaning convection sections or descaling hotspots on tubes. It's all about maintaining the process unit between turnarounds. I'll mention two of those services at the end of this presentation, but our focus today is on the CTEC ceramic coating, that product line. So this is a proprietary thin film ceramic coating that we have designed to operate at exceptionally high temperatures. So that's why it's such a great fit for fired heaters. So we have coatings that go on the radiant tubes as well as refractory surfaces. And all of that is about improving the radiant efficiency, keeping the operational reliability intact, and of course, lowering emissions along the way. I thought it might be a good place to start to just get a sense of the variety of heaters that we typically work on. So if you're in downstream, most of these heaters would be names you'd recognize. Under the steam methane reformer family, whether it's hydrogen reformers or primary ammonia reformers and fertilizer plants, they all have that potential to enjoy not only the fuel savings that you see there and productivity benefits, but folded right up into that come the CO2 and NOx savings along the way. And I did want to make sure that I pointed out there's two family of coatings that we look at, that we've developed, and we use them independently based on what we can do to maximize the benefit within a given heater. Because again, it's about the right coating on the right surface area in order to get the longest benefit possible. Because these coatings last multiple years. Think of it as 2 turnaround cycles. And it's important that we have a full view of each of those heaters. So let's go to the basics for a moment. Radiation, furnace radiation. So how efficiently the radiation is transferred to the radiant tubes is all about emissivity. A zero emissivity would represent a perfect reflector, not what we want, right? We want to have a black body situation, meaning an emissivity of 1. What that really means is the radiant energy that hits that surface is absorbed and re-radiated back into the furnace chamber over a broad spectrum wavelength. So that creates the opportunity for the maximum heat transfer. So if the ultimate enclosure is an emissivity of 1, anything less than that simply means that we're losing heat transfer efficiency, we're wasting energy, using too much fuel, elevated bridge wall temperatures, essentially creating unnecessary CO2 and thermal NOx. So let's take a look at the first family of coatings, the high emissivity ceramic coatings, which are specifically designed for refractory surfaces. So when you build a fired heater, refractory, there's a lot of versions to be used, and they're chosen for their affordability, ease of construction, their superior insulation value, all the things that go in and make perfect sense in building the unit. But the one piece of that puzzle that falls short is the actual emissivity. And you can see by the chart, think of ceramic fiber board and blanket at the low end of 0.45, and working your way up the ladder, if you will, on the brick and castable. We want to take all those low emissivities, all those inefficient numbers, and bring it up to 0.92 with our ceramic coatings. By moving that, we're getting much closer to the black body, the 1 emissivity, if you will. And so putting the coating down increases the radiant heat transfer that you would normally see, in this case, at a lower rate at 0.45. So re-radiating more energy back into the process means you need less energy overall for your barrels per day. You have less wasted energy going out the stack. I did want to touch on some of the background calculations, if you will. Lobo and Evans and others have produced this mathematical explanation in terms of high emissivity coatings, how they actually work, and how it improves the radiant heat transfer from a refractory surface to the tubes. Now, to be fair, this calculation does not consider the radiant heat going directly from the flame or flue gas to the tubes. But in this calculation, it does show how the radiant heat from the walls can essentially be doubled. So to maximize QR, or the heat transfer, F must be minimized. So by increasing the emissivity from 0.45 to 0.92, F is then reduced, and therefore you're increasing QR. So it's behind the scenes, if you will, on the calculation side, but it is absolutely legit science for this technology. So long story short, high emissivity refractory coatings absorb and re-radiate the energy back into the process in a more useful wavelength. So we're reducing your fuel firing, therefore you're lowering CO2 in kind. And if it's a more efficient radiant section, by default, you're lowering your bridge wall temperature. Therefore, you're lowering your thermal NOx. So the two go hand in glove, if you will. Now, the beauty of the technology is if you're in the busy season and you need to kick up your production and you want to take advantage of the savings from the coatings, now you can do, let's say, 8% more barrels per day instead of on the savings side of it. So you can shift as your demands require year over year, and think about that over 2 turnaround cycles. A lot of flexibility from the coating itself and how you want to use it. So from our perspective, why wouldn't you maximize the radiant energy capture rather than simply letting it exit the stack? And I would also say in parallel to not only the CO2 and the NOx, there's another environmental win, which is the encapsulation characteristics that you get from ceramic coating. On ceramic fiber, which we all know at some point will become oxidized, will tend to dust, and that dusting crystallization will end up going downstream into your convection section, right? It's not a good situation, certainly in the long term. So if you apply a ceramic coating to that surface, it will stop that crystallization, which of course is one of the root causes for that fouling. I guess I would say that it's important to recognize that rigidizer is a product that's traditionally used in the industry to solidify that fiber, and it does a fine job in the short term. We want to do something more than that and cover that entirely with the ceramic, because now you've got the emissivity to help on the radiant efficiency, but you also have the whole encapsulation to prevent the downstream dusting. Again, another adder to the whole environmental equation, if you will. All right, so we just talked very briefly about the ceramic coatings and refractory. Let's pivot to the tube coatings. So this is the other family that's formulated specifically to be applied to metal. Now, regardless of the metallurgy that's involved, we coat 2 1/4 chrome tubes, 5 chrome. The most popular is 9 chrome, 1 moly. All of these surfaces are going to oxidize. At some point, you're going to have objectionable scale, which leads to the problem, right? The oxidation is a barrier to the conductive heat transfer to the process. So you're taking a hit on your efficiency, you're losing barrels per day, you're impacting your margin, all the things that these units are not made for, right? We want to run that at optimum efficiency for as many years as possible. So in every case, on the process tubes, in these fired heaters, it is a great situation to lock them into a like new condition with the ceramic coating, because it is a barrier to stopping the scale from growing. So rather than trying to turn up the burners and overcome the insulating scale, let's lock them into a new position, a like new condition. So I wanted to talk a little bit about the whole heat transfer coefficient, because it gets into the thickness of the scale, et cetera. And so people ask about the insulation value of the ceramic coating. So our thin film ceramic coating, think of it as transferring heat just about as good as bare steel would, a brand new tube. But a brand new tube, as you all know, it isn't long into the first year where the scale begins to grow and continues to grow for quite some time. So if you have scale, that's interfering with the transfer of energy to the point where, think about, it's half as efficient as ceramic coating. It is a legitimate impediment. So coatings, what do? They'll elevate and maintain the radiant efficiency in the years to come, and stop even the metal loss from the tubes themselves. So again, you don't have to overfire, you're saving fuel, lowering CO2. And also along the way, if you're in a situation where you're operating in a place where you're fighting carburization, outside diameter carburization, we also can bring that benefit to bear with the coating. So if you want to seal off that surface and prevent carburization in the long run, exactly what ceramic coating brings to the table on the tubes themselves. So let's look at IRs for a minute, because we all live with those reports and we know how they can be problematic, especially if you're pushing the unit a bit, you're wondering what your tube metal temperatures are. Well, the beauty of ceramic coating is we have a known emissivity, we have a known coating thickness, and so therefore the heat transfer coefficient can be used, and we can calculate the tube metal temperature. And that's what I'm trying to show in this picture right here. So on the left, before coating, the heater's been in service for a number of years. You've got a good bit of scale on there, substantial thickness. So the thicker the scale, the higher the surface temperature, and the delta here between the tube metal temperature and the surface temperature is about 360 F, call it 200 C. So this corresponds to a scale thickness of about 1/8 of an inch, or 4 millimeters. Now this is a significant barrier to conductive heat transfer, and all that does is raise your CO2 and your NOx emissions. But after coating, if you look at the shot on the right, the thin film ceramic coating stops oxidation. The IR shot shows that coating provides a much lower barrier to conductive heat transfer. Now the delta T between the tube metal temperature and the surface temperature is more like 40 F or 20 C. So at the end of the day, this is exactly the improvement you want in your fired heater efficiency. This would be about an 8% fuel savings, an 8% CO2 savings, and that comes out to about a 15% NOx reduction also. So all of that folds into exactly how the coating is going to perform. And we thought it would be a great way to just show, if you will, 1 year later. Okay, so environmental emissions, right, under that umbrella. Obviously, CO2 is directly related to the fuel consumed. We can make an impact there. NOx is related to the flue gas temperature, and we're lowering that bridge wall temperature without a doubt. And I mentioned the particulate, meaning we can lock in the refractory fiber so that you don't have downstream dusting. And at the same time, we're lowering the operating cost, lowering your fuel consumption, improving the reliability because of the infrared images so you can maximize your production without being concerned about crossing some sort of safety envelope on hotspots on a tube. We're preventing OD carburization. And all of these roll up into a long-term performance package. I did want to say something about NOx, though. I think it's important to mention that there are multiple sources of NOx, and that thermal NOx is what we're really referring to here. So keeping that in mind, when we look at your heater, our evaluation process requires us, excuse me, to consider tail gas and purge gas, refinery gas and fresh gas. I mean, because that varies by the plant and the heaters themselves. And so we look at all of those data points and components to make sure that we have a full understanding of how we can impact the efficiency of that unit. As a matter of fact, if you think about more hydrogen in the fuel is less CO2 reduction. And so when we look at heaters around the world, you could see a range of, let's say, hydrogen from 5 to 50%. And all of that rolls up into our modeling and our evaluation and subsequently the recommendation we would make for your heaters. I wanted to go to an API 535 recommended practices chart because I think the NOx isn't just intuitive, and I thought this chart might be of some help. So in this graph, it's simply pointing out if you're lowering your bridge wall temperature, in this case by 100 F or 55 C, then you're looking at a 15% thermal NOx reduction. It's very straightforward. You just have to take advantage of getting these coatings in place and look at your particular economics for that heater. So if I catch my breath for a minute and give you a sense of NOx and CO2 by heater family, this will give you a sense of the average emissions that we have seen in the past. So our process is to look at your specific design, to look at your actual operating data. We're going to marry that together with perhaps infrared images if it's required. And then we can model the best benefit of the combinations of coatings in the surface area that we think can do the longest performance for you. And that way we can come back to you with a return on investment, a price, a timeline, all the safety documents that are required, because at the end of the day, not only do we own the process, but we're the applicators of the process. So for us, it's a turnkey relationship with you. We want to be in front of your process engineers, in front of your safety folks, and work in tandem with your turnaround people to make sure that all of those fit together so that you have the right project at the right turnaround. And again, this is our business model, but these kinds of percentages would be exactly what we would expect to see from those different families. I would also want to say two things: that the coating life, we really do live in that 2 turnaround window is where you get the maximum benefit. And at that second turnaround is when you're going to make your next economic decision to replace the coating and your payback issues. And so that's exactly why we want to be in touch with you, not only before the project, but after the project to do a post-coating evaluation. And then, of course, we would get involved with you in each subsequent turnaround to see what supports your production plans in the future. One of the questions, I should have gone back in the tube coating process. Oftentimes I'll get a question about the coating's ability to not only have cohesion, but adhesion to the tubes themselves, thermal expansion kinds of questions. And the coatings are absolutely designed to survive that cycling, turning the units on and off, it won't be a problem for the coating to, it is not going to come off of the tubes, if you will. So let me now pivot to the true approach that we have to support you. Let us get involved with your design specifications. If you've done some upgrades to the unit, we want to be involved with that. If you want us to sign non-disclosure agreements, that's fine. We certainly treat documents with the highest confidentiality. And so we may bring our infrared cameras in, but we absolutely want to look at those general arrangement drawings, and we want to organize a scope and a benefit and a timeline, as I mentioned a moment ago, to make sure that you have all the information you need. And that begins with looking at your design specs, because we want to look at absorb duty, look at radiant efficiency, inlet outlet temperatures, all the things that you would love to have in a brand new unit. And we're going to figure out how close we can get you back to that situation. And of course, hold you in that position for as many years as possible. Here's a snapshot of a case study I thought would be interesting. In this case, it's a catalytic reformer. Relatively sort of a mid-range, smaller unit, 16,000 barrels a day. But if you look at a 6.5% benefit, that's kind of in the mid-range. We have a lot of benefits that are higher than that. But in this case, I thought it was a great picture for the culmination of, for instance, fuel savings, right? This customer is looking at just over $1 million in fuel savings. And in their world, CO2 is absolutely emerging very quickly, so it's a great value add for them. There's another $500,000 in CO2 savings right there. So just on the fuel CO2 component, this customer is getting a payback of less than a year. And as I mentioned earlier, you have the ability to pivot during the life of the coating. Some customers look at it as over the course of a year, I'm going to have 10 months of fuel savings and then just 2 months of, they call the busy season, right? And so you put that together and you're still looking at a benefit of less than a year. So it's all a matter of combining your operational expectations in the future. If you're in the unique position of having to just full on capacity increase, well then, geez, the payback is less than 6 months. So all of these variables are important for you to make the right business decision, but that's why we need the relationship to work with you on all of the components that come into this. So let's pivot to a different fired heater, a different size. Here's 23,000 barrels per day. As I mentioned, 9 chrome, 1 moly, pretty common tubes for us to coat. A good bit of fiber on the walls, a little bit of brick. And this is a low end of it, right? We took this just to give you a sense of the range that you can have. And that's why every heater has to be looked at on its own merits. So here we're looking at a 3.5% fuel savings capacity increase. And in some cases, folks take advantage of process severity. So at the end of the day, as I mentioned, we do our pre-evaluation and we have full support as a post-evaluation for the coating. And you're looking at the kind of results. These are the agreed upon results with our customer. So process absorbed duty, fantastic, it goes up. The fire duty in all the cells going down, exactly the things you would like to see from a customer. Quick payback on this. We're talking about, because they were in a unique situation of taking advantage of the capacity increase, paid itself back in 6 months. And then, because of the life of the coating, you continue to get that payback. It's a real win when you think about getting any turnaround is looking for the best projects possible and the greatest payback. And if you're talking about a 1-year payback on any project, certainly those are worthy of consideration in almost any turnaround I've been involved with. But what does that really look like in the infrared side of it? I wanted to go back to that for a minute and just emphasize how important the reliability component is here, because it does have a situation here where the infrared on the left is typical of what we see when we take our FLIR cameras out and go ahead and take shots. And you're looking at, what, 650C, right, 1200F. We want to get you to what the shot is on the right. We want a much more uniform temperature. We don't want to worry about hot spots. We want to be able to have your tubes look like that for year over year. And that's where the real win is, especially on the operating side. You're not having to guess your tube metal temperatures. So again, a nice snapshot in terms of the life of the coating, because that's always a great question. How long does it run? So now I want to talk about primary reformers for a minute. And just because we touch a lot of different families. Now, Obviously, there's a lot of configurations out there, top fired, wall fired, terrace walls, lots of rows, not many rows, all those things. Those are all important because we have to, again, be able to marry in the emissivity of the coating, the best surface area to put the coating. Do you have flame impingement issues, exit gas temperature? All of those things come into play to dialing in your performance benefit. So in this case, we're talking about a Foster Wheeler. Here's just a 2-slide summary of that case study. 900 tons per day, traditional convection section, things you would expect to see. Auxiliary firing, bridge wall temperature of 380 F. And here's a snapshot of what that refractory coating would look like getting applied. Remember, we're the developers of the process, the owners of the coating, and not only are we responsible for the formulations, but the application of it. So this gives you just a sort of a background check of what it looks like when we're applying it. Again, no VOCs. Here, all water-based formulas. Curing takes place at your startup. There's no hold points like you'd have in a refractory. So take your unit right up to operating temperature as you will, and that's where you'll get your proper sintering, if you will. So at the end of the day, what does that case study look like? Well, long story short, because of all the work that was done in that unit, it was some 600 gigajoules a day they saved. Sorted through the other work that was done in terms of apportioning the benefit, and we were left with a pretty good piece of that 600 gigajoules a day, 360. So that's a 4% fuel savings. Again, the CO2 comes right along with that, directly attributed to that coating performance. So if you lower the bridge wall temperature in this particular case by 90 F, you're essentially looking at about a 13% NOx reduction. This is why it's important for us to work with you before and after on these projects. Another snapshot from a project on a SMR. Numbers aren't so easy, a little too small here, but if you're looking at flue gas temperature, they're down, stack temperature down, all the things you would expect to see because the coating is doing its job from its high emissivity point of view and of course from the encapsulation side. So when you think about the ratio of fuel consumed for hydrogen production, it should decrease after the coating because you're using less fuel to make more hydrogen. And then that's the win. We also lowered the NOx from 135 to 96, and the fuel consumption, right, is in tandem with the CO2. Again, a nice win, a good brief snapshot just to introduce you to our summary of the kind of performance you'd expect to see from our coatings. Now, if you're in a unique situation and sometimes it's a great situation because you're going to replace all the tubes in your fired heater, you're revamping. This is another wonderful opportunity to take full advantage of that coating and get it applied to the tubes before installation. We have shops that we can do that in. We'll coat the tubes, cure the tubes, seal them up for safe storage. Now you've got tubes that literally will be kept in a like-new condition for years, and the flexibility during the turnaround to install them at your convenience, if you will. So what a great option if you happen to be going down that road. Another way to extend the life of those tubes. So now I'm going to pivot quickly. I mentioned we had 2 of our hot tech services I wanted to make mention of. And the first is vacuuming of catalyst. So in some parts of the world, if you're operating an SMR, you've got catalyst on the backside of that, right? And everybody knows that's an expensive item. And in some cases, that will get fouled up. And when you do that, now you've got serious issues. Do you limp along to the turnaround? Do you cut it down early? Do you have a sister unit that can pick up the difference, whatever that may be? But we've developed an online vacuuming approach that we can go to the unit and enter the unit with our vacuum head. It's shown on the upper right-hand corner of that shot. That vacuum head is designed to pull that fouling off of each of the, I'll call it squares, right? There certainly are 200 of them in these situations, but we can clean that surface without damaging it and get it done over, think about it as 4 or 5 shifts, relatively short window, but it gets you back to full operating instead of having to limp along, if you will. So here's maybe a better before and after picture. Again, no damage from the cleaning head. We're doing it while the unit's operating. Obviously, it has to be negative pressure, but you're not having to cut rate. These shots actually were taken with our Landscope, our high temperature camera, so we can view the work simultaneously. The access ports, we create those online also. So we have a nice turnkey approach for the online ability to get you back to not being in this cut rate situation. Again, it does roll up into the whole emissions end of this equation. So on this particular unit, over 5 shifts, we cleaned 90% of the surface. That payback was well under a year, and it just took the better part of a week to get it done. So getting the pressure drop reduced to the near starting point, huge win for the customer. It's like starting over. It's like starting a new run just by doing the online cleaning. The other topic I just want to touch on here is convection section cleaning. Of course, this is the classic before and after picture because it's exactly what we're able to accomplish. Get in between the bundles while the unit's operating, and using our dry ice and high temperature lances, we can get these fins cleaned without damaging the fins. You're not going to have any thermal shock damage, things like that. But it's important to look at the real numbers at the end, because that's what really gives you the benefit, right? Let's look at what that is, the base case. So the fire duty decreased. That's exactly what you want. The total absorbed duty stayed the same, which means we improved the heat transfer using less fuel. So the flue gas or the exit temperature decreased. That means more energy is transferred to convection tubes, so increased steam production. This was a payback of less than 6 months. So in this particular unit, they're saving 6 million BTUs per hour. If you just assign a $6 value to that, that's $300,000 in fuel saved. Then you put in the CO2 on top of that. In this case, it's about 16% of the dollar. So it's about another 50,000. So you're looking at a $350,000 savings for this customer. That's a win. And that's what we're asking for, the opportunity to look at your situations and see what we can do to help you from a payback standpoint. So this is the last slide, just giving a setup of what we do in terms of working off the deck. We're using line of sight with our operators, putting the lances into the inspection ports. Just a way to give you a sense of how that looks. And coming back to the last slide here, because I know time is short and I went a little long, but again, just a reminder of the NOx reduction and the CO2 reduction, the averages that we see among different families of heaters. And of course, we're asking for that opportunity to work with you on your particular units to dial in that performance for you. Thank you for letting me go through that.
Thank you very much, Larry. So now we'll take some questions from the audience. First of all, we've had a few questions about the lifetime of the coating. Mm-hmm. So how many turnarounds will it last, and what is the time between turnarounds?
Yeah, think of it, I said 2 turnarounds because that really is a great way to get close to that answer, because some folks run 4 years, some people run 6 years and all that. But that is usually the ideal recoating, is at the end of the second turnaround. But the coatings are, do a fine job in that 8, 10, 12-year window. So anywhere in there is the right time to shut it down and
So
recoat.
What happens to the coating after the second turnaround?
It's a do-over. Meaning if it's on a tube, we're going to reblast the tubes, get it down to the right profile, the right cleanliness standard, and then reapply the coating. If it's on the refractory side, it's really a matter of gently cleaning, because a lot of that refractory will stay intact for quite some time. So we're not going to tear off the coating off a refractory. That's just not going to make sense. We'll sweep it down, blow it down, comb it down, and then reapply. So it's a little different procedure, but either way, you're getting a new coating, because that's where you get the maximum benefit for the next 10-year run.
Thank you, Larry. Next question from Ahmad. Coating applied on the refractory, will it increase the life of the refractory, or would the refractory last the same without the coating?
Oh, great. I mentioned earlier, rigidizer is pretty common to put down, I mean, industry standard. And of course, you're going to get that friable problem, right? At some point, the fiber is going to get damaged and tend to suffer. So yes, the ceramic coating, which puts an eggshell on it, if you imagine, is going to protect that fiber and give it a longer life, because it really will. That's a very durable skin, which will hold up against the flue gas.
Thank you, Larry. A question from Eileen. Generally, refineries use refinery fuel gas or natural gas as a fuel, and these gas systems are considered as clean fuels. So when you consider these fuels, is it still valid to apply a tube ceramic coating?
Absolutely. Because what do we say? The devil's in the details, right? So let's look at exactly how much hydrogen, what's your fuel composition, what else are you trying to get done with that heater, and roll up all the benefits and rank them based on the value it has for your operations. So absolutely not a waste of time.
Great, thanks, Larry. Question from John. Are the coating benefits maintained for the entire life of the coating?
Okay, so there is, at some point, it is a sacrificial coating. So there will be some decline, which is at the very end of life. I mean, some folks imagine it's a dead decline, if you will, over the whole 10 years, and it is not. It maintains its veracity, if you will, for nearly the whole run, and you'll see some degradation at the end. And that's where you make that business decision.
Hey, Larry, let me just add something to that.
Yeah, go ahead. Thanks.
Yeah, so as I was saying, that the coating maintains its benefit for a good amount of its life. Then towards the tail end, couple of years, it decreased a little bit. But after 2 turnarounds, the benefit just doesn't go to zero. It starts to decline a little bit in the first couple of years after it's deemed end of life, and then after it becomes more of a rapid decline. At that point, after 2 turnarounds, it's the best to reevaluate if the coating is needed for a recoat.
Sort of a glide path, if you will, in its decline. Thanks, Paulo. Good call.
Next question we have from Nikelling. Will the coating prevent scaling formation? I'm guessing that's the tube coating.
100%. Yes, please. That's exactly what we want to do, right? In addition, we want to stop carburization if you're fighting that.
Great. Question from Javed. How long does it take to apply a coating to a typical catalytic reforming unit set of heaters? And for new units, is it better to ceramic coat the tubes in a fabrication shop or in situ in the heater after the heater's construction?
Well, lots of implications in those questions. So there are very few turnarounds I can think of in my 12 years that we ever missed because we wouldn't fit within the turnaround window. So to work in the box during a turnaround, whether it's a 7-day or a 17-day event, just comes down to the size of the unit. We have the ability to expedite crews, and so can't think of more than one time we just didn't fit in the turnaround. So that usually isn't the issue. But I think there was the other question about shop applied coating. And if you have that unique event, it is wonderful to have the flexibility in the turnaround, to have all the coating already done, coated, cured, and waiting in the laydown yard. So it's really more of a timing question. And usually turnarounds are based on days, right? And so the more work we can get done outside of that, the better. It's just like when we're cleaning the catalyst or convection sections. That's all done outside a turnaround. It's a huge win, because you don't have that burden. I think that went down the right path.
I think it did, Larry, yes. And a follow-up question from Javed. Do you always use your own labor to apply the coating, or do you engage labor local to the installation?
We are our own crews. So you'll see IGS logos on the FRCs and the hard hats. I can't think of a set off, if you will. Maybe if we needed extra labor for some moving of product, like a forklift or something. But no, that you want our trained people on those guns, either blasting the tubes because of their experience and putting on the coating because it is important to get the proper thickness in order to get the right benefit of the life. So it is our responsibility. It is our people.
But they could be local people because we have multiple staging areas.
Well,
Right.
if we do a if we do a fired heater at Astron in South Africa, well, we have a crews, right, that live in South Africa, or crews in Thailand or Czech Republic. So yeah, it's certainly those overlaps happen all the time.
Thank you, Larry. Question from Ivan. How is the coating resistant against acids, specifically sulfuric acid?
Boy, that's a tough one. I think I'm going to defer to Paulo and see if he can step in on that whole question, because this is a dry, high temperature coating.
Yeah, so it's going to depend on process conditions of the atmosphere, and mostly like dew point. If the temperature's low and there's going to be some dew point where the acid might actually like become liquid on the tubes, that could be an issue. So it's best if we look at it in a little more detail than just trying to give a blanket statement to the coating and sulfuric acid conditions.
Of course, and if we're talking about power generation, right, that's a whole nother path where our technology is used, and if whoever asked that question wanted to reach out to us, we can also talk about that if it's a coal burning situation.
Next question from Amir. Do you offer this technology to the reformer heater suppliers for newly built ones, or only applicable to the running ones?
I'm sorry, I think I hear Tim's presentation rolling in the background.
Let me remove the stream. Is it better now?
I think it is.
Excellent. So I think you've answered this before, but just to clarify, do you offer this technology to the reformer heater suppliers for newly built ones, or only applicable to the running ones?
We would love to apply it in brand new heaters. Please. That would be a win all the way around for you, because you really are going to lock in those refractory surfaces in a like new condition for a much longer time.
Another question from Javid. In hydrogen reformers, I presume you only coat the refractory and not the tubes, which are of high alloy.
Thank you for asking that question, because it's right. In that situation, refractory is the surface. We would not be coating the radiant tubes in an SMR unit, hydrogen reformer, primary reformer. We just wouldn't do that on the tubes themselves. So thank you for that clarification. It's absolutely true. So the answers of which coating to use are very specific to which heater we're talking about, right? And so if we're talking about a coker or a crude or a vac, I mean, all of those are very important to what we can offer you. So thank you for that clarification. It's exactly the right thing to say.
Great. Question from Alfredo. In coker operations, the heater tubes are being mechanical or steam air decoked on a routine basis. Is the refractory coating capable to handle these extreme conditions, extreme heat cycle?
So you're doing that on the inside of the tube, right? I mean, we're not, I'm not aware of our refractory coating being damaged by that event at all.
Good. During the hot convection cleaning, does the heater need to be turned down?
No. I guess maybe the way to say that is, it's rare that it ever is, but we want to be in a negative pressure situation, right? That's I mean, when you open those inspection doors, you obviously don't want anything coming out at you. And that doesn't happen when you do your normal inspections. And this would be the same situation. We're just going to open one inspection port at a time. Very small situation in terms of potential risk.
Thank you, Larry. Question from Mohammed. What effect will be on the coating during the heating due to thermal expansion mean linear expansion?
Yeah, our coatings, we've gone through all of those testings years ago, quench testing, thermal shock, the things that you would be very concerned about, right? Because you don't want that coating peeling off, if you will, or failing. And so we're quite comfortable. You can't take the heater up fast enough to damage the coating. You just can't physically get there. You have hold points on other normal refractories that you have to hold, 400 degrees, so many hours, and ramp up, those kinds of things. We're not even under that jurisdiction. So you won't hurt the coating.
And I suppose there wouldn't be any effect of abrupt temperature change during emergency?
No. Shut it down, take it down, whatever you got to do. the coating's going to ride right along with you.
I feel like you touched on that before, but if you could again clarify. Question from Jordan: why don't you propose tube coating for ammonia SMRs?
Yeah, those high alloy tubes really don't suffer from much in the way of scale or oxidation. They're just not building up anything of any appreciable level. So the benefit isn't really there. But if we were talking about stainless steel tubes, I'd have a whole nother discussion about increasing the natural emissivity of brand new stainless steel. So again, if you have a heater you'd like us to look at, we can drill down on the specific coating for that exact application, because the answers will absolutely vary based on what we're trying to accomplish.
Thank you, Larry. Question from Madison: is the coating performance affected by richer, more hydrogen than a more typical natural gas fuel, or is it relatively constant?
Not a concern for us. Goes into the calculations of the benefit, certainly, but it's not going to have a positive or negative impact on the coating itself.
Question from Bala about how the CETA coatings, after being in the industry for many years, are now connected to the ESG score.
Ask that again. I'm not sure I understood.
I suppose that we focus a lot on return on investment in terms of dollar value, but now we're talking about the emission reduction and how that plays into the improvement of the ESG score.
And I think that's an individual answer for each organization, each refinery, and what their requirements are, right? We have customers that call and say, we've got a permitting level of X, and if you can lower that on these 2 heaters, you're going to help me stay underneath that number. That's the value that we're bringing. How that rolls up into the bigger score is something that I think is a different conversation for the actual end user. But that flexibility that we bring can be very valuable.
And I guess we know that we reduce these emissions, and reducing of these emissions are directly related to the improvement of the ESG score.
They roll right up into those, I'll call it those early victories in this world of environmental awareness.
Thank you, Larry. And Bala, if you have follow-up questions on this, we can discuss this after the webinar. Question from Ahmed: does the coating affect the efficiency of the reforming process inside the reformer?
Only in that if you wanted to raise your outlet temperature, if you will, process severity, that's where the value would come from. If that was what you were trying to accomplish, the coating will let you get to that higher outlet temperature. If that's what your goal is for some, like the busy season, to increase your process severity, you can dial that up and the coating will support that.
Thank you, Larry. Another question from Mohammed. Will the coating allow the actual measurement of a hotspot?
Yes, because number one, you're not going to have the hotspot, right? That's the real win, because the coating will prevent that scale from occurring. So you'll be able to know your true tube metal temperature by virtue of the insulation value of the coating, which we know, and the infrared images we're taking. So we can dial right in on what you'll have. That's actually one of the bigger drivers for customers that do suffer from hotspots, where they have to consider curtailing rate. That's a rough meeting to be in. And so if we can get all those tubes back into that like new condition, you're not having to combat that at all. You're just taking it off the table.
Thank you, Larry. So we now will go to the chat. We have some questions there. So question from Marcus: the fuel savings that you mentioned in your presentation, are those numbers based on what the end users gave you, or did you determine them yourself, and based on what?
No, we do that together, right? If you want real numbers, you got to sit down with the customer and you work through exactly the same data questionnaire we use up front to gather it and look at the process. We come back later once the unit is stabilized and gather the same data from the control room with the same process engineers. It's a hand in glove event in terms of verifying all those numbers. Because isn't that really what has to happen at the end of a turnaround? You're up and running, you spent X on a project, you have to report back how that's operating, what was the win, things like that, and we're part of that relationship.
Question from Alfredo: the emission reduction numbers, how many cases roughly would you say they are based on, to your knowledge?
Well, the ones I showed were ones we did. I mean, I thought it would be best to actually give real world, like, here's this customer, we work with them before and after, and here's what those numbers were. It is interesting, though, how much more the CO2 question comes into play now. You know, it would just be in pockets 5 years ago, and now it's pretty common. Pretty common that the energy engineer gets involved and they bring to the table some of their goals and what they're trying to do for a given site, not just the CO2, but the NOx, and they try to fold that in. So it's much more common now than it ever has been. So think of it as regional and probably based on the cost of fuel is another driver.
Thank you, Larry. Question from Daniel. How do you repair spots with missing coating in between the furnace wall and the radiant tubes?
How do we repair coating? Well, the only time you can apply coating is in a turnaround. So it's got to be cold. So that's one. Number two, if the damage to the refractory in, let's say, the first turnaround, right? It's 4 or 6 years later, they're in inspecting tubes. We're not going to do anything, but scaffolding beats up the refractory for some reason in and out. We can go touch up those areas. Pretty straightforward. Very simple, you know, touch up bucket blaster, touch up gun, and put it back to good.
Thank you, Larry. An interesting question from Jason. So you mentioned CO2 savings from combustion. What is the CO2 cost of the making of the coating?
I would say uncle is my answer. I don't know that answer off the top of my head. I'd like to defer because I just don't know that answer. Thank you for hitting me with a question I didn't answer. I'm going to go look that one up and make sure we get that for the next webinar.
We definitely will. Question from Ahmed. Do you think the steam consumption will increase due to the coating?
Steam. Well, we're not if you're talking about the convection section, then we're not coating those tubes. So it wouldn't be appropriate to coat the tubes in the convection section. However, it's very appropriate to get them as clean as possible and keep them clean. So maybe I'm not understanding the question.
We can always follow up afterwards
Yep.
if there's any question that is unanswered. I
Sure.
think, Larry, your friend Bill Waymer is here. He commented that it's a great presentation and it was great to see you again, and he hopes to see you at the next API this year.
Thank you, Bill.
Will you be attending, Larry?
I better. I'm not retired. Let's go to work. I want to get back to work. Let's get more of that.
Thank you very much. I think that was probably the last question. Maybe you could explain to everybody potentially what could be the next step in requesting the evaluation and how the process goes.
Right. I mean, really the 30-second commercial at the end here is you can see that we have a very legitimate technology. We have a process that can help you. We just need to be invited to your facility to look at your heater. Let's look at your design specs, your operating data of the day, and we'll come back to you with that complete answer and see how that folds into what you want to do in your next turnaround. So if you've got let's say you've got a turnaround in 22 and a deadline of October this year, let's get that data from you now, turn that around, and you can do your own internal justification based on our feedback and how that project stands up against everything else you're going to do in your turnaround. Because you've got to evaluate that based on improving the unit, improving the site, and of course, corporate funding. And if I'm bringing you a project that has a payback of 15 months or 10 months, certainly those are very strong projects. We would just appreciate that opportunity.
And a follow-up question about the evaluation from John. The question is the evaluation free of charge?
Yes, it is. Please bring us in. We'll do good work. We'll give you the modeling, show you where you can be. That's our relationship with you, because we're going to be connected with you on multiple heaters over multiple turnarounds.
Great. Thank you, Larry. And I think on that note, we will end, and we wish you all a great day.
Great questions. Thank you very much. That's fun for me too.
Thank you. Thank you, Larry. Great presentation.
Bye now.
Bye.